I'm Dr. Amanda Norbutus, and welcome to Chem 1046, or General Chemistry 2. This is your second semester of General Chemistry, and we're going to be building on what you learned in Chem 1. We're going to build on our knowledge of atoms and molecules. We're going to build on how they are shaped. We're going to build on acid-base chemistry and oxidation chemistry, not reduction chemistry. We're going to learn about why and how. We're going to go a little further and do a little bit more math. So when we think about this, we discussed bikes in first semester, where we said, okay, does a bike spontaneously rust? Yes. Does a bike spontaneously go back to pure metal? No. But now we're going to talk about why not. We're going to talk about, is it a spontaneous reaction or not a spontaneous reaction, and what is the energy associated with both types of reactions? So we're going to go a little bit further. So a little bit about myself, just to kind of explain how I got here. When I was in college, I was a senior and I was a pre-med person, and I actually had a major in history as well. So when I was taking history, I was taking chemistry, and I was taking other things like biology and physics, and it was a lot of reading, it was a lot of math, and it was a lot of lab. So I feel you when I know you can get overwhelmed and stressed about all the materials. But sometimes you just have to find that why. Why are you going to that class? Why are you doing chemistry? Why are you finishing this up? And so I want to know your why. And because I'm going to ask you your why in our first discussion post, I want to tell you my why. So when I was a senior, I took that course. As I said, it was analytical chemistry and art, archaeology, and forensics. And I thought I was going to do forensics, be a medical examiner, do something like CSI. But I fell in love with the art, and it blended my love of history, my love of analytical chemistry, and the ability to do some research. So I took that love and I went to grad school. And in grad school, I traveled across the continents. I went to Amsterdam to figure out what this painting was for. You know, I went to England and I went to a historical estate of a duke to figure out who bought this painting and where did they sell it during their history. I also tried to figure out how in the world did it come across to America and end up on eBay. Weird story. That was part of my research. I had to figure out the history. I had to figure out the materials in there from the chemistry. What pigments were used? Was this a fake? Was this original painting from the 17th century? And it took all of my knowledge from my bachelor's degree and my master's degree and ultimately my PhD to get some of these answers. And so that's what we're going to do in chemistry. We're going to get a lot of information new, but we're going to build on it from Chem 1. And that's kind of how I did my research. You always take what you know, you try and find as much as you need to know for the next step, and you move forward. And so this is kind of a story of your whole academic career. You need to figure out what do you need to know to get to that next step, and how can you best take that information that you learned from prior semesters and apply it to this semester. So in order to do that, there's going to be a lot of things that we're going to go through. We're going to have lecture, we're going to have videos that we share, we're going to do homework, we're going to do labs, and we're going to have what I call problem-solving sessions, where we're going to actually go to solve problems step by step, so you can see how I would approach them, and I also see how you would want to approach them, because it doesn't have to be my way or the highway. It has to be how's the best way for you to answer that question, because science has an answer, and usually about 6 ways to get to that answer, if not more. So we're going to figure out which one's the best pattern for you. And I just want to remind you that chemistry is fun. It can be cool. I wanted to know, why do paint fade? Why are ghost appearings in paintings that make no sense, that hadn't been there for 100 years? Answer is polymerization. So I had to learn how do things break down chemically and how they respond to real life. Sometimes you might have a question about, why do medicines work? Why, if I mix certain cleaning materials, do they create a noxious fume or have a very powerful cleaning side? What can you do to be more green in your life? These answers could all be found in relationship to chemistry. So let's try and find your why this semester. Again, are you pre-med? Are you nursing? Are you engineering? Are you just trying to figure out how to get through your science class? I want to know your why and how we can apply it in our classroom. The other thing I want to say is, I know it can be overwhelming to be in a Chem 2 class. There's a lot of new knowledge coming at you. There's a lot of math, and I want to make sure that you don't hit that wall where you're so overwhelmed, you just say, we're done. That's not the purpose of going through chemistry. It's not just a class that you have to suffer through. We want to make sure that you succeed and you do it well and you enjoy it as much as you can while you're trying to solve all these problems in the mysteries of the chemical world. So when you get that feeling of overwhelming, awareness of where you are in chemistry and how much you need to know, take a moment, take a breath, and reach out. You have your classmates, you have our class tutor, you have the Valencia tutors, and you have me. I have office hours on Zoom. You can reach out to me through email, you can reach out to me through Canvas message. And again, we're all here to make you succeed, to help you succeed. We want to make sure you get there from day one to the finish line at the end of the semester. And I'm not going to lie, it's going to be work, but if you put in the work, you will be successful. Okay? We're going to be having lectures. And I do highly encourage you to attend lectures because, hey, the more you hear it, the more you see it, the more you read it, the more you'll know it. And I cannot highly praise enough coming to those problem-solving sessions. They are optional. I'm going to be honest, they're optional. But the best way people learn things is by explaining how they solved that problem. I'm not going to be the one solving them all the time. Hopefully, as we go through in the weeks, you'll feel more comfortable sharing how you approached a problem or listening to how another of your classmates approached that problem and seeing if it matched your approach or was a whole different way. So we're going to learn from each other as well. And then as we get toward the end of the semester, you realize that everything you learned over the couple past semesters of chemistry, whether for 10, 25, and 45, or just 45 itself, you're going to see how that applies in Chem 1046. And you're going to understand, why do things happen? Why do certain reactions work? Why do certain reactions not work? If you ever did that volcano experiment in elementary school, middle school, or high school, why did certain times that volcano erupted violently? And how come sometimes it just fizzled and went, eh? And that has to do with kinetics and rates of expressions. And we're going to go through all of that this semester. I can't wait to explore science with you. I can't wait to explore more about the chemistry of our world with you. And I hope that you come along with me and share what you want from chemistry with us in the classroom. Take care, and I'll see you soon in class.